Merci beaucoup, Martin. Avec les derniers progrès de la transformation numérique qui permettent de créer toutes sortes de systèmes, des systèmes capables d'apprendre par eux-mêmes, des systèmes qui sont capables d'exécuter par eux-mêmes, de décider par eux-mêmes, on voit qu'il n'y a pas de limite actuellement à la transformation numérique des organisations. Puis, c'est en quelques années que tout ça s'est passé. On voit ça arriver dans tous les secteurs des organisations, en construction, entre autres, autant en gestion de projet, en logistique, en gestion de chantier, en gestion dans les camions, dans le transport, en collaboration inter-équipe. Donc, toutes sortes d'outils que vous avez vus depuis les 5 dernières conférences nous mènent à penser qu'on peut vraiment intégrer toutes sortes d'éléments pour s'améliorer dans nos réalités quotidiennes. Donc, on voit aussi que c'est un incontournable, que c'est là pour rester. Alors, d'être ici aujourd'hui, de vous informer, c'est un élément fondamental pour vous amener plus loin. On aura un conférencier très intéressant aujourd'hui qui va nous parler des jumeaux digitaux, des jumeaux numériques. La construction digitale fait partie intégrante de son quotidien. Monsieur Richard Humphrey va nous présenter une conférence qui est intitulée The Construction Project Digital Twin. Je vais vous le présenter. Richard Humphrey est le directeur principal de la gestion des produits et de la stratégie des produits chez Bentley Systems, entreprise axée sur la prestation de solutions de construction. Il compte plus de 20 ans d'expérience en marketing et en gestion de produits de haute technologie. Plus récemment, à titre de vice-président du marketing chez B2W Software, où il a dirigé la stratégie de marketing pour les produits de construction lourde. Il a été pendant 10 ans directeur principal chez Autodesk, où il a dirigé le secteur des logiciels de conception de construction civile. Titulaire d'une maîtrise en génie civil de l'Université Carnegie Mellon, il a commencé sa carrière dans l'industrie de l'architecture, du génie et de la construction en tant que gestionnaire de projet pour le Army Corps of Engineers et Clark Construction. Richard possède le titre de PA Lead et a travaillé avec les chefs de file des industries des bâtiments et de l'infrastructure pour favoriser la conception durable, l'innovation technologique et la BIM/VDC. Alors, Richard, it's your turn. Have a nice conference.
Oh, thank you. Appreciate the introduction. I will share my screen and we'll get going. So thanks everyone for joining today. As described, I'm going to review the application of a digital twin to construction project delivery. I'm going to start a little bit with a review of some of the specific examples of the business value of leveraging a digital twin from design through construction. I'll provide a little bit of background first, really starting with construction in general. I think we all understand that it's a huge and really important industry that impacts people's everyday lives and global economies. But winning the right projects, creating effective plans, and managing the risk and project execution is really hard. So many construction firms that I've talked to are challenged with managing the chaos a project represents in terms of making sense of thousands of documents, managing tens of thousands of issues, and coordinating them across hundreds of resources on a single project. That they are under pressure to drive productivity and efficiencies in this environment in order to deliver compliant projects on time and on budget, which is clearly have been very, very difficult. But the outlook also doesn't look, any easier for construction projects. So the situation is in fact getting harder. For example, the demand for infrastructure continues to expand, and as a consequence, so is the complexity associated with these projects. So project size and design complexity has been increasing as new tools have enabled more sophisticated designs. But the more significant impact that I see is that there's an increasing delivery expectation from the owners who want continue to get more for less, transfer risk. They want higher quality controls, increased health and safety standards, especially in the new normal of COVID that we're seeing, greater transparencies, even now the public expects to see increased transparencies, including 3D visualizations and simulations to better understand the project. And ultimately, projects need to be delivered more sustainably. Resource scarcity is also increasing. So lack of skilled labor, we continue to see that, higher material costs, and large capital equipment utilization being key. And finally, there's never been more data available to construction firms as more information is transferred from the design phase, and mobile devices and sensors become prevalent on job sites, exponentially increasing the availability of project data. However, there continues to be issues in how how are construction firms going to use this data so that it's better managed, connected, and accessed by the people that need it to do their work. There continues to be data silos where 30% of companies use applications that don't talk to one another. Poor data quality where 90% of the data isn't structured, so it becomes really hard to use downstream. And the result is that on average, only 4% of the available data is leveraged or used, but the average worker spends about half a day a week looking for that data. So all this data is hard, it makes things hard, but it's also the most significant opportunity for construction firms that they have today, leveraging this data to make better, faster decisions and making it more accessible to project teams with the latest technology can significantly make project planning and project management easier. And this is what we're going to talk about. So a little bit of history, right? Clearly we're ripe for technology adoption, but we've been on a long journey. We've evolved from, say, 30 years ago, where the industry made a digital transformation and it went from paper and introduced CAD, which was, basically what we're doing was taking paper processes and automating them, into the computer. For construction, the first workflows to be automated were scheduling and estimating and accounting, basically all the work that was being done on spreadsheets. The next disruption that we saw was when we moved from CAD to BIM, or 3D models. For construction, we saw the emergence of desktop and web-based project management applications and document control software. Recently, we've seen the emergence of mobile as the platform for construction, as we begin to see paper field forms being digitized and field staff referencing and collaborating on that data in the field, including 3D models in the field. So we're simply moving to the next stage of our evolution. It's taking some time, but we have a significant convergence of new technologies that's enabling us to move beyond a static BIM model to digital twins during the delivery process. So let's talk more about what I mean by the digital twin and how it's applicable to construction. So let's start with a question. What if we could digitize the construction processes so that we were better organized data around a single source of truth and common data environment? We simplified the access to that data for everybody, so it was available to them anywhere, anytime, based on what they were doing. And what if we provided project performance visibility based on real-time data accuracy, accurately captured in the project context, and we'll talk about that more, so that better project decisions can be made to ensure optimized project outcomes. So ideally, for all projects, it's key to better know where you are on the project in terms of space and time and cost or budget. Ideally, we'd have access to real-time data in context. So again, of location, work breakdown structures, and other schemas that make sense during the construction process. So everyone is on the same page. You also would more easily find the latest information in one seamless digital environment, as I described as well. Next, you'd want to clearly know where you're going with planning tools that optimize resources, reduce risk, and ensure projects are on time. And finally, you'd want to know that you can get there faster by better connecting resources and automating workflows such as quality and safety, so the teams spend more time working on value-added activities and less time on non-value-added activities. So thus, the way we see us getting to that point is through a better implementation and evolution to what we describe as a digital twin. So quick definition of what the digital twin is: it is a digital representation of a physical asset, process, or system, as well as all the engineering information that goes along with it, so that you can better understand and model its performance. The key here is it's continuously updated or synchronized from multiple sources. It's connected from more connected to the actual building project itself. So no longer static, it's live, evergreen, continuously updated. So so kind of more of the evolution of, instead of trying to push BIM to the construction project or to the field, it's more like pushing the field data up into BIM. And ultimately what it enables is data-driven workflows, including asset visualization, status checking, performance analysis, again, in the context of the model. And like I said, the digital twin has really been made possible because what had been emerging technologies are now becoming more ubiquitous in the market, and those technologies are converging. And some of those include mobile devices. Everyone is familiar with, has a smartphone now, but drones are becoming more prevalent. Reality capture on the job site is more of a reality. It's being used continuously for continuous surveying on some jobs, so that they can get progress and understand the job site conditions and do site monitoring. But we're also seeing that combined with the emergence of artificial intelligence, machine learning, the Internet of Things or sensors, and mixed reality on the job site. And all this comes together to really enable a 4D model that delivers a construction project digital twin. So a couple concepts. One that's really important, I may mention it before, about aspects of the digital twin. And the first one is really around the context of the asset. So every road, every bridge, every building exists somewhere on the planet with its own unique set of geospatial considerations. In other words, it has to know where it is. And it also has to, when you do a project, it's important to understand the environment around that asset that is to be built. And this could be enabled through, historical information, but it's really made easier to grab that context at the beginning of a project now through reality capture and the creation of mesh models that combine with BIM models. Another really critical dimension of the digital twin is time. There's nothing static, as I described before, about a construction site. And so things are constantly changing. The BIM model can't remain as a static tool for us to do our jobs. We need to apply the sense of time and be connected in real time to things that are going on out in the field. So as shown here, the digital twin persists over the life cycle of an asset. There can be multiple digital twins throughout the life cycle, from planning to design. It leverages reality models and engineering creation to construction models tied to job site and asset operations. As more information is added to the digital twin, the availability of insights and values that can be driven increases. So there's multiple digital twins here. I'm really going to focus on this session around the construction digital twin and how it's created and how it's leveraged after it's set up. So let's take a closer look at this construction digital twin lens. So it all starts with the aggregation of several data inputs or sorts of data, including first the engineering and design data or engineering and model information from the design process. Next, it's how you need to go turn that design model into really a construction model by adding construction information during pre-construction planning to augment that model so that it has the context and schemas that make sense for construction, and then ultimately feed in the information during construction operations from sensors and crowdsourced information, as I described, from mobile devices. These sources, like some static, but many near real-time feeds, make up this rich project digital twin and enable the transformation of workflows. And it kind of, as shown on the right, I've kind of had this laid out as inputs and outputs, but those outputs are the construction workflows and the resulting information and artifacts and tasks that come out of that. For example, 4D planning and simulation. Leveraging a model and tying the schedule directly to the model really is a transformative process that drives step function improvements in how people plan and interpret schedules during pre-construction planning and during construction. But other examples include doing 5D modeling, so quantity takeoff and estimating based on the model, but also tracking progress and real-time resource tracking against the model, and then having the model be the interface to business intelligence. The result of leveraging these outputs and these workflows is a step function improvement in productivity. So when I describe productivity improvements, and keeping this as the digital twin as a backdrop, again, we ask that question: what if construction project delivery could be made easier by deploying the digital twin via the latest technology solutions? What if we could get time on our sides and avoid change orders and minimize project risk through better planning and project coordination? What if we could reduce the time required to estimate a project, say from 2 weeks for a large complex project to a couple hours, so engineers and construction firms can bid more projects and bid them more accurately? What if we can avoid up to 75% of costly rework and material waste and reduce the actual schedule, compress that schedule, because we have more accurate, we can be more accurate about our schedule before we get out into the field and better communicate our plans to construction staff so that they're more efficient. So I want to look at some examples of the technology I'm talking about that's helping to do this. And we'll start with this pre-bid use case, right? So construction firms I've talked to, they're always looking for ways to change how they do project pursuits. They want to win more projects, and they want to be able to reduce the time they have to do those in order to be able to manage more risk and ensure that the projects they do win are profitable. So one customer was looking to change their existing process for design build projects. They'd previously spent a lot of time trying to make sense of design documents, which came in the form of PDFs, CAD files, models, and other information sets. But they didn't have a good way to leverage the information that was coming in from designers, because the platforms that the design bid documents were created in really weren't suitable for construction planning. So as a result, they spent up to 40% of their bid effort trying to derive quantities from the engineering document sets they got. PDFs and spreadsheet-based processes they had were prone to errors, omissions, and estimates that could result in either not winning the project or not, making the project they did win a struggle to become profitable. And they just were under time constraints. They didn't have the time to go investigate other options to manage risk and identify profitability opportunities. So to solve these problems, the contractors I'm talking to, particularly the one I just mentioned, they're looking for purpose-built construction modeling solutions, as shown in this graphic, to make sense of the design models and develop a construction model that they can use for downstream workflows and improve how they do their business, including model-based quantity takeoff and estimation, but also planning and project controls, which I'll talk about. As shown here, it all starts with aggregating data. So whether it's design data, reality meshes, or standard data formats like IFCs, the ability to pull them into a single, simple cloud-based construction environment that enables the creation of a construction model is key. And I want to talk a little bit more about that. So the next step of the process would be, look, I've got an aggregate model. It's coming from a lot of different sources, but not all the model data is appropriate for me to be able to leverage as a construction model. I often need to split models into phases and constructible components so they align to how the project is going to be built. This is particularly important for, I would say, infrastructure projects that are horizontal or civil projects where the civil design models, more often than not, don't represent how they're going to be built. For example, a 10-mile corridor design model object is one model object. That needs to be split by phase and means and methods in order to be useful for construction. Then we want to be able to assign, an easy way to assign construction attributions such as work breakdown structures with cost codes and quantity calculations, or time and other schedule logic, all pulled into a single digital twin model. And then ultimately the result of pulling together a representative construction model with construction attribution during pre-construction planning is the ability to extract quantities from the model that can be verified visually, so that you avoid the errors and omissions in the current that you see in the current process. Resources have more time to add more value in terms of risk management and scenario analysis, and optimize their proposals, and ultimately better connect the estimating process with the scheduling and sequencing process, because everyone's working off of a common construction model. So I wanted to run through, what does this look like quickly in a real world example. So what you're seeing here is all the steps I described, an aggregate civil model in this case. And first step would be I want to break this model into phases or work areas. Well, in this particular tool enables that quickly, splitting, cookie cuttering in this case, models elements into discrete work areas. So those work areas become children to the overall design models as well. But then you want to go and interrogate further in a particular work area. In this case, we're looking at a retaining wall. This retaining wall could be miles long and have different elevations. So you want to be able to split it both horizontally and vertically. In this case, we're splitting it on the vertical to represent the different lifts. So now I've quickly split this retaining wall, and we can apply work breakdown structures and means and methods that are appropriate for each lift. As a high, for example, the higher you get in this wall, you're going to use different methods for how you pour the concrete potentially. Other examples of splits, but ultimately, again, as I described, the net result is a model-based quantity takeoff, where the quantities are based on the calculations from the contractor and how they do work. So net is I quickly have a construction model. In this case, where it's an example of how we use model-based the model to do quantity takeoff, but I end up with a verified report. And if something changes, the design changes, the model updates, you don't lose any of the work that you've already done. So I want to move on now. We also want to move to the next phase, which is scheduling and planning, where construction firms today really have, it's difficult for them to try to visualize and understand the complexities of a project based on 2D plan sets. Their current process is time consuming, it doesn't provide an easy way for planners to evaluate this in different scenarios. And like the estimating process, that you can make mistakes, and those mistakes in timing and sequencing cause downstream project delays, cost overruns, and lost productivity for field staff. So we want to be able to change how we do this again with the digital twin. So customers I've talked to, they're using this model-based scheduling, leveraging the model that was already aggregated and that I based on the example I showed for quantity takeoff. But in this case, what you're seeing now is I'm adding schedule logic, tasks, and resources to that construction model. So I end up with a complete 4D, 5D model, all coordinated in the cloud. This enables planners to view the schedules, the staging, and ultimately simulate in 4D so they can optimize plans and resources quickly by visualizing multiple plan options. So avoid errors and omissions by running through your plans in a virtual digital environment rather than making mistakes in the field where they're costly. This also helps a lot of people use this as a way to visualize and simulate how they're going to build it even during the bid proposal process so they can win more projects, and ultimately taking this type of plan and schedule and handing it to the production team during execution enables a much easier path for communication, and even crews leveraging it in daily stand-ups for digital rehearsals for complex construction processes. Again, very effective in terms of driving efficiencies and productivity from the planning into the operations phase. So I want to move on to the operations phase. So once the project moves into execution, the users describe that they have a trouble staying on the same page, right? Everyone wants to ensure that they're working off the same plans. They want to have real-time visibility on project performance from the field so they make better, faster decisions. They want to be able to manage tasks and documents more efficiently. And they want to ensure that the field can access and capture the data needed to do their work and keep the projects in control during operations. But what we find is, as kind of represented in this picture, is that the current processes aren't optimized. They still rely heavily on paper, spreadsheets, and legacy systems that aren't connected, are error-prone, and not real-time. The field and the office aren't always connected, and they basically lack a single integrated source of truth. So to address this, again, contractors are turning to, in construction firms in general, turning to newer, better technology that's cloud-based and to manage project management tasks as well as document controls. So it's critical that project task information can easily be organized and managed in a simple, single environment that's purpose-built for construction. And it's the case that you're seeing here where it easily enables the access to data and with quick links to see what's going on, to manage your tasks, to manage the project tasks, create new information, and also track it. So what we're seeing here is a typical interface where all the information is organized in a single web view. So you got focus tasks, the commonly used tasks, review of both your own tasks as well as the overall project information. And again, everyone has access through this web portal to all the information they need. So in this, again, leveraging this web-based solution, I've talked a lot about single source of truth, but also in this presentation, it's all about serving up data in the context of the project. Again, that means that the data is aligned to the way construction firms in the construction process need to represent it, which is the work breakdown schema with data accessibility in different forms so that it's served up in a way that's meaningful in the easiest way for the particular person based on where they are and what they're doing. So in this case, you're seeing a typical registry or list view, but we also want to be able to see that same information, say in a calendar or Kanban view, but also scale up to GIS maps or georeference PDF views to access and manage the information and create new information, but ultimately scale to the full 2D and then 3D, 4D, 5D digital twin as the context to access and manage information. So specific types of data that can be accessed and managed, and just as an example would be, how do we manage documents, plan sets, and models, creating, marking up PDFs and managing those document sets, creating issues and RFIs, daily logs and reports, inspections, and even schedules are all managed in one place and can be managed in the context of time and location and of the model. So project management, again, in the context of location, time, and the model, this makes it a much easier way to find the information you need and improve coordination, collaboration, and communication across the extended project team. So this video is demonstrating the value that I just described, right? So as you go through document management, task management, and then ultimately leveraging all the information that's being pulled back from the field into this common location, you can start driving real business intelligence with reports and project dashboards as well. The result of using this type of solution that leverages the model as well as other contextual means that everyone is going to be working on the latest plans. So we do avoid rework and lost time. The extended team has improved communication and coordination. Field staff can quickly access the information they need, and near real-time, high-quality data is captured again in one place, so we make better, faster decisions and keep projects, in control. And as shown here, it really scales from all the way from kind of a 2D up to say 3D, 4D, and details, but also large-scale projects. So, but construction does happen in the field, and so we need to manage that as well. But there are also not good tools today, and as a result, we get poor efficiency sometimes, and rework and non-value-added work from our field staff because they can't access the information they need. They struggle to capture it quickly in a structured way, and it's difficult for them to coordinate with the extended team on the job site, but also with the office. I mean, they're still using paper processes, a lot of spreadsheets, which again are inefficient, not real time, unstructured, and error prone. So to solve this, the field needs to access the data they have, and the way to leverage the technology is through simple, easy to use mobile devices that can be online or offline, so they can easily find the information they need based on where they are and what they're doing. Again, delivering the data in context of task views, map views, detail views, or the model to be able to better do their work. Just a few examples of the context of what can be delivered to the field to enable these teams to perform better. So in terms of capturing data in project context, it's important also that all stakeholders can collaborate in real time. So the types of data that are captured in fields, for example, include issues, observations, RFIs in the field, inspections, daily reports and daily logs, time tracking, crew tracking, and progress reporting and progress tracking, either with a model or without a model. So let me get quickly into an actual example of this type of application in action. So first we're able to easily navigate our documents, but in this case, we go straight to a 4D model, and the user leverages their GPS location to identify themselves in the context of the model and select the actual model object or asset that is where they see an issue or they're inspecting. So this makes it really easy and quick for them to get to the exact form that they need, and then capture that data in context of location in actual model space. And then we're also seeing advances in terms of how do we use AI, and in this case, natural language voice transcription to simplify the data capture process so that the field can capture more data more quickly. In the process, has reduced errors and omissions, and it's just easier for them to capture the data right there where they have in particular in this case example, a phone first application that they're constantly carrying around with them. So some construction companies have also matured beyond what I've just described. So their digital processes and their model-based workflows that they're looking at are looking to extend the value of the construction model that they've created by leveraging, as shown here, advanced rendering simulations, mixing the model with the reality information from the field, and using augmented and virtual reality to allow project staff to take working in the project context to a much more immersive experience. As shown in these examples, we've got customers that have asked for solutions that scale from 2D workflows to 4D and 5D model-based workflows and beyond to drive greater efficiencies. So what I'm showing here is really compelling in terms of kind of if you start down the path of building a digital twin and you connect your field staff to that digital twin, the amount of what you can get out of it is really up to you in terms of the possibilities for increased efficiencies and productivity. So as I described, the digital twin has the potential to transform how construction projects are delivered. And it really does this in two ways. It delivers the continuously updated and live single source of truth for construction so that we ensure that all stakeholders have the latest information, they're all on the same page, there's improved data access, again in context, and it also drives business intelligence, leveraging AI and possibly machine learning so that you have better reporting and make better, faster decisions. And it also has the capabilities, number two, of transforming some of our workflows. And we talked about 4D planning and simulation, 5D model-based quantity takeoff, reality capture for progress tracking. There's also robotics and machine automation's already been happening driven by a model for a lot of civil projects. But all these processes have really changed and resulted in step function improvements that weren't possible without a model or digital twin. And I'll kind of start to wrap up a little here, but the examples that I showed you were all examples of Bentley's latest construction solution called Synchro, our new cloud-based construction portfolio that delivers an integrated and connected set of solutions that are enabling the iTwin in construction to happen. It's based on Bentley's iTwin platform, and as shown here, the Synchro portfolio includes really three core offerings today: Field, which is our field management solution, all native mobile applications; Control, which enables project and document management, all based on the web; and Synchro 4D, which is today the industry leading solution for construction modeling, planning, and virtual construction, as well as I described, other workflows such as model-based quantity takeoff, and soon driving planning from CPM scheduling to production planning and work planning in the field. Additionally, we're, at Bentley currently working to add synchro cost to manage bids, budgets, and change orders. So stay tuned for that if you're interested to find out more. But ultimately, the digital twin for construction delivered through Synchro is helping infrastructure construction firms pull engineering and construction data together into a single environment to help them win projects, deliver them more efficiently, and increase profits. And ultimately, for everyone, all the stakeholders on the project, drive better optimized project outcomes and make construction planning and delivery easier. So that's all I had for today. I think we have a little bit of time for Q&A, but thank you for listening.
Thank you, Richard. It was very interesting. Ce que je constate, c'est que tous ces outils-là permettent de gérer un projet du début à la fin de façon tellement efficace qu'on parle de la soumission, de l'exécution, du contrôle, donc plein d'éléments vraiment intéressants. Le 26 novembre prochain marquera notre 6e et dernière conférence. Au menu, vous aurez 3 conférenciers qui aborderont le thème de la construction durable avec des structures composites et bois d'ingénierie. Les conférenciers seront M. Hugo Germain du groupe Germain, Joël Larouche d'Obrella et Pierre Mierski de Lemay Michaud Architecte. Donc, nous vous attendons à ce moment pour vous rencontrer pour ces conférences. Pour ceux qui sont dans le VIP, demeurez en ligne. Nous nous retrouvons tout de suite après cela à la conférence VIP. Alors, merci à tous et bonne journée.